Alright, so this is Unit 7 CDE test review. Number 1, we're identifying the number of zeros for the polynomial shown. The number of zeros, there's 3. 1, 2, 3. So there's 5 total solutions. And there are 3, and they all go across through the x-axis linearly, so 3 real solutions. And this is 5 total, 3 real, that means there's 2 imaginary. Finding those solutions, well, they're right on the calculator here. So x equals negative 4.7, x equals 6.5, and x equals, we'll round to 3. And they're all single solutions. Number 2, describe the possible solutions of a polynomial with degree 15, so that means there's 15 total solutions. Exactly 3 real solutions. So there's 3 real solutions and 15 total solutions. That must mean 15 minus 3, 12. And we can have 12 imaginary solutions because they're always in pairs, even numbers. Moving to the next one, we have minimum degree the polynomial. So minimum degree the polynomial can have if it's at least 1 imaginary. Well, imaginaries cannot be odd numbers, so they got to be even. So 1, 3, 5, or 2, 3, 5. Oh my goodness, 2, 4, 6, 8. They got to be in pairs. So first we look at our graph. We have 2 real solutions. So that's the very least, so our degree is at least 2, but then we have to have at least 1 imaginary solution, so we can't have 1, so the smallest we can have is 2 imaginaries, which is degree 4. 2 plus 2 is 4. Over on the next one, very similar. So this polynomial has a degree 9, and I know in class we talked about the slopes. This has 1, 2, 3, 4, 5 slopes, so you'd think it'd be degree 5. If I don't tell you the degrees, then yes, it'd be degree 5, but since I tell you it's degree 9, this has 9 total solutions. So the biggest exponent is 9, even though there's only 5 slopes. It can happen. There can be more solutions than slopes. So we still looking at our x-intercepts. There's 3 x-intercepts. They all go through in a linear fashion, straight line. So there's 3 real solutions. So 9 minus 3, so that means there's 6 imaginary, and we can have 6 imaginary, so that's good. That's an even number. Looking at the next one, so our next problem here, I put it in Desmos. We have 3 total solutions, and looking, there are 2 real solutions here, but one of them at negative 2 forms a quadratic shape at the x-intercept, so that is 2 solutions so there's 2 here and 1 that comes through the x-axis, very straight line there, so that's 1. So there's 3 real solutions and no imaginary. Alright, moving on to the next one. I'm going to do synthetic division on this because the coefficient of what we're dividing by is 1. And how I do synthetic, I'm not going to change the sign. You could change the sign, but then you'd add. We're more welcome to do that. We're going to look at our exponents, 3, 2, then 1, then it technically is into the 0. And so that's great. The exponents go down by 1, so we just pull all the coefficients. So 1, negative 6, negative 9, negative 8. Bring the 1 down. Do 1 times 1 is 1, and then we're going to subtract. Negative 7. And then we do 1 times negative 7 is negative 7, and then we subtract. 1 times negative 2 is negative 2, then we subtract. Alright, so we look, n to the third divided by n is n squared. So our first coefficient here, our 1, will be at n squared. Then we're going to step it down by 1 on the exponents, so 7 n to the first minus 2, and our last number is a remainder of negative 6. We can clean this up a little bit. N squared minus 7n minus 2, and it's a remainder of negative 6. You could do that, or you could do plus negative or minus negative 6 over n minus 1. Either way. Alright, next problem, I'm going to do the exact same thing. We're going to do synthetic again. So it's 5 goes inside. Look at our exponents, 3, 2, 1, and technically to 0 power. So that means they all step down by 1, the exponents, so we just pull all the coefficients. And we're not skipping any terms here, so that's great. We do 5 times 4 is 20, subtract it, negative 3. 5 times negative 3 is negative 15, subtract it, so subtracting negatives is a plus. So that's negative 21 plus 15 is negative 6. 5 times negative 6 is negative 30. Subtracting them, that'll be 4. Your exponents are going to go down by 1 here, so it's going to be the coefficient 4n squared minus 3n minus 6, going down by 1 each time, with a remainder of 4. There's your answer. Let's move it on to the back. We have, now our coefficient is not 1 of our what we're dividing by. So we got to use long division here. So 9x minus 10. 9x cubed minus 91x squared. Oh, we're missing a term. Careful with that. 0x. So I'll put plus 0x plus 101. Take your first term, divide it by first term, and that will be x squared. Now you multiply back down. So x squared times 9x is 9x cubed. 9x squared times a negative 10 is a negative 10x squared. I put parentheses around it and subtract. So 9x cubed minus 9x cubed. Well, those cancel. Great. Negative 91x squared minus a negative, so that's plus. So that's going to be plus 10x squared, so that ends up negative 81x squared. Bring down our next term and take your first term divided by first term, so negative 81x squared divided by 9x is a negative 9x. Multiply back down, so negative 81x squared. Negative 9x times a negative 10 is a positive 90x. Subtract, and your 0x subtracting 90x is a negative 90x. Bring down our last term, and we have first term negative 90x divided by 9x is a negative 10. Multiply back down, so negative 10 times 9x is negative 90x. Negative 10 times a negative 10 is positive 100. And did I do that wrong? I did that wrong. Negative 90x divided by negative 10 is a positive 10. Alright, I panicked. I thought it was wrong. Long day, I guess. So it is a negative up there. Negative 10 times 9x is negative 90x. Negative 10 times negative 10 is positive 100. When you subtract these, we get a remainder of 1. So you get x squared minus 9x minus 10, and the remainder is 1. Alright, let's look at 7e. So 7e, we have zeros at negative 5, 1, and at 0.5, which is also 1/2. So we have, looking at our, those are solutions. We want them to be factors. So that's what I'm doing here, is I'm changing them so they are factors. X plus 5 is a factor. X minus 1 is a factor. Now with 1/2, we got to treat this a little differently. We can't have fractions as factors, so change is divided by 2, so we multiply by 2, and then we can subtract 1. So this factor is 2x minus 1. Now the factored form of the polynomial, I put f of x, you can put g of x, y equals, don't really care, but it should be equals because it is polynomial and it should be a function. We need to multiply these out. So when you multiply 2 terms at a time. So x times x, x squared, x times negative 1 is negative x, 5 times x is 5x, and negative 5. Let's simplify these. X squared plus 4x minus 5 and 2x minus 1. We need to multiply that out now. X squared times 2x is 2x squared minus x squared plus 8x squared minus 4x minus 10x plus 5. Getting our like terms together. Let's turn this sideways. F of x equals 2x squared. Oh wait, you should be yelling at me. That should be cubed. Cubed. Thanks for yelling at me. Plus 7x squared. The middle two are like terms, and our last two are like terms, minus 14x plus 5. Alright, when it comes to the roots of 0, 2i, and negative 2i, roots means the exact same thing. X equals 0, x equals 2i, x equals a negative 2i. This is already a factor. X minus 2i is a factor, and x plus 2i is a factor. So we need to multiply those together. I always choose f of x. You really don't need to. You can have g of x, h of x, y equals. Really should try to go to f of x or h of x or something like that would be good. What I tend to do, you have three factors. You can multiply any two at a time you want, but since the second two look alike with the imaginaries, I would multiply those out.